Hey guys, welcome to the 2015 Level 2 Calculus exam. So in this session I'm going to be covering the whole exam paper, guys. The best way for you to learn is to pause the video at the start of each question, try the question by yourself, and then see how I go about the answers. What I'll also be doing is telling you guys what you need to do for achieve merit, excellence, and so on. Okay, let's get started with the first question. So in this question we've been given f of x, and we're asked to find the gradient of the graph at the point where x equals -1. So one of the things that I like to do is I like to actually just write down what the question is actually asking. So in this case we're actually looking for the gradient when x equals to -1. So this is what we're looking for. Okay, so we've been given f of x. So f of x is equal to x4 plus 2x squared minus 5, which means f dash of x is equal to 4x cubed plus 4x. So at this point I need to substitute my -1 where x is. So I'm going to get 4 multiplied by -1 to the power of 3 plus 4 times -1. And when I simplify this, I get -8. And this is an achieved question. Okay, let's go to question 1b. So 1b, we've got this function and it's asking for what values of x is f a decreasing function. Now, for you to have a decreasing function, that means the gradient has to be negative. So what we're looking for is, so if you think about it, we're looking for when is f dash of x less than 0. So our first step is to figure out what f dash of x is. So I'm going to write down f of x first. So I've got 8 plus 3x plus x squared minus x cubed over 3. So when I differentiate this, I'm going to get f dash of x equals 8 becomes 0, 3x is 3, x squared is 2x, minus x cubed over 3 would become minus 3 x squared over 3. And of course the 2 3's cancel out, and what I'm left with is 3 plus 2x minus x squared. This is what f dash of x is. So from this point there's actually quite a few ways you can do this. If you'd actually been watching my level 1 videos, what we're looking for is basically this is what we're looking for. 0 has to be less than 3 plus 2x minus x squared. Now you can actually sketch this as a graph, and that's what I like to do, sketch it as a graph, find the x-intercepts, and then find out for which zone the gradient, well, the values are going to be negative. So the first thing I'm going to do is I'm going to actually solve this question here, but solving it in terms of putting it equals to 0. So what I'm going to do is I'm going to put 0 equals 3 plus 2x minus x squared. Now, I don't like dealing with negative x squareds. I want to make it into positive x squared. So I'm going to bring everything from the left-hand side to the right, from the right-hand side to the left-hand side. And when I do that, I'm going to get x squared minus 2x minus 3 equals to 0. Now I can factorize this. So this would become x minus 3 times x plus 1 equals 0. And I can say, therefore, x is equal to positive 3 or -1. Now guys, unfortunately for this question, you have to do it up to here to get an achieve. But how do we make this into a merit or an excellence? So let's actually look at this particular graph we're looking at. I'm looking at this graph right here. Okay, what do we know about this particular parabola? We know that it's a negative x squared, so the parabola is going to look something like this. What we also know is that we've obviously got x and y axis, something like that. And my two values, which is 3 and -1, are the roots. So this value here is -1, and this value here is positive 3. So if you think about it, which zone is negative, you can kind of see that, let me just see, everything before -1 is negative and everything after positive 3 is negative. So we can basically say that the function is decreasing. So we can say that function is decreasing for x less than -1 and x greater than 3. Now guys, this is just one way of doing it. There's another way you can do it as well, where you can talk about the original equation, which is here being a negative cubic. You could do second derivative or just checking of gradients as well. So there's quite a few things you can do. But I think the final product is what gets you an excellence. If you make a minor mistake, you'd get a merit somewhere in that question. All right, let's go to question 1C. Okay, so for this particular question, we've got calculate the rate at which the volume of a cube is changing with respect to its length at an instant when the length of each of the edge of the cube is 5 centimeters. Okay, so first thing we know is that volume of a cube can be written as x cubed. Because if you think about it, I mean, if you have, say, volume of a cube, you've got x, x, and x times x times x is x cubed. So that's our equation. So we're trying to figure out what the rate at which the volume is changing with respect to its length. So we can say that v dash of x equals to 3x squared. And then at this point, we've got the edge of the cube is 5 centimeters. So we're trying to figure out what v dash of 5 is, which is equal to 3 times 5 squared, which equals to 75. And I guess the way we write it is that this one, if you think about it, it is the rate at which the volume of cube is changing with respect to its length. So if you think about volume of cube, that's going to be centimeter cubed. And then if you look at it with respect to length, it's centimeters. So what we're trying to say here is that for every 1 centimeter increase, the volume is actually increasing by 75 centimeter cube. That's what we're doing. Units is not required, guys, according to the schedule, but I just wanted to put it down there to show you guys the understanding behind it. So this is what's going to get you a merit for an achieved, just this part right here. Okay, let's go to the next question. So we've got train passes a signal at a velocity of 40 meters per second. The train's acceleration is given to you guys in a formula. It's asking what is the greatest speed attained by the train after it passes the signal. So we can basically say that, you know, for it to find out what the greatest speed is, acceleration has to equal to 0. So the first thing we're going to do is we're going to figure out at what time the acceleration is going to be 0. So we've got 16 minus 2t equals to 0. And rearranging this, we've got negative 2t equals negative 16. And t equals negative 16 divided by negative 2, so t is equal to 8. So what we can say is that at 8 seconds, that's when the greatest speed happens. So we got to figure out an equation for the velocity itself. So to figure out velocity's equation, we've got to integrate acceleration's equation. So v of t would then become 16 minus 2t dt, and integration of this. So v of t equals 16t minus 2t squared over 2 plus c. Now the important thing is we know that when it passes a signal, it's traveling at 40 meters per second. So we can say that when t equals to 0, velocity equals 40. So if we were to substitute it in this equation, so we're going to get 4t equals 16 times 0 plus minus, well, 2 and 2 disappears to leave me with just t squared, so that's all right, I'll just put this anyway, plus c. And what you should see at this point is 40 is equal to c, and our velocity function is equal to minus t squared plus 16t plus 4t. So that's just coming up with the equation. We still haven't figured out what the greatest speed is. So we need to figure that, we've got to put v of 8, because we know that at 8 seconds, that's when the maximum speed is happening. So we've got negative 8 squared plus 16 times 8 plus 40, and simplifying this, we're going to get 104 meters per second. So grades wise, getting that final answer gets you a merit, or equation for a velocity gets you an achieved, or getting t equals to 8 also gets you an achieved. Okay, now we go to part 2 of this question. So part 2 of the question says, how far past the signal does the train travel before it stops? Okay, so what we do know is, we do know the velocity function. Velocity function was v of t is minus t squared plus 16t plus 40. So if the train has to come to a stop, we know that the velocity is equal to 0. So I'm going to put 0 equals negative t squared plus 16t plus 40. And obviously I need to factorize this, or actually no, not factorize, I need to solve this. Now at this point what I'm going to do is I'm just going to put these 3 values in the graphics calculator, guys, and get my 2 solutions. Alright, if you don't know how to do that, check out one of the other videos that I have, which is graphics calculator tips, and you can actually see how to get solutions given a quadratic. So what we then have is, from here we can just say t is equal to 18.2 seconds, or t is equal to negative 2.2 seconds. Now unfortunately we have to kind of say that t can't be negative, because this is actually looking at how far past the signal does the train stop. So if you think about it like this, let's say this is, okay, that's a terrible signal, but you get the idea. The train, trying to draw a train, there you go. Okay, so this is where t is equal to 0. We know that velocity is speed is 40, and then after 18.2 seconds the speed is at 0 and also at negative 2.2. so 2.2, it's also at 0. But because the question is asking how far past the signal, we're actually looking at this particular one, so we're actually looking at 18.2 seconds, and we're going to ignore t, the t being negative. So we have to kind of state that t must be positive. Okay, but just be careful. Sometimes it's always good to kind of visualize this kind of questions just to see how you can answer it. Okay, so we've got that. What we are trying to figure out is the distance between here and here, because that's what we're trying to figure out. Now in that case, when t equals to 0, I can put s is equal to 0. When t equals to 18.2, I want to know what s is. That's what I'm trying to do here. So to figure out s, I know that it's the integral of velocity function. So velocity function was negative t squared plus 16t plus 40 dt, and that's the integral of it, which means s of t is now negative t cubed over 3 plus 16t squared over 2 plus 40t plus c. So one of the things I'll show you, something very useful for you guys to know, is this. When t is equal to 0 and s is equal to 0, we can actually state, therefore c is equal to 0. We can actually do that. You might want to know why, but have a look at this. All right, if I say that s is equal to 0 because the distance is equal to 0, t equals to 0 means this part is 0. T equals to 0 means this part here will also be 0, and 40 times 0 will also be 0. Now if you got 0 equals 0 plus c, then you have to say that c has got to be 0 as well. So that's what I'm doing right here, which means then I can say s of t is equal to minus t cubed over 3 plus 8t squared plus 40t as my s function. So when t equals to 18.2, so it's just a matter of substituting these values in. We've got negative 18.2 cubed over 3 plus 8 times 18.2 squared plus 40 times 18.2. And when I do this, I should get an answer of 1,368 meters. Okay, so grades wise, that's your excellence. For achieved equation with distance c equals, so probably achieved somewhere here. sorry, not achieve, that's merit, to get the equation, or even up to here, find valid values of t. So merit up to here you could get just finding the correct value of t. So achieved, obviously you've got a whole lot of other things that you could have done to get achieved, like for example that there, solving valid two answers for t. Yeah, so it's a few things you could get achieved for. Cool, that's basically it for this question, guys. We go to question 2 now. All right, let's go with question 2. We have gradient of the function is given by f dash of x. We got a point. We got to figure out what f of x is. All right, so what I'm going to do is we can say that f of x is integral of 4x minus 3 dx. So then f of x is equal to 4x squared over 2 minus 3x plus c. Now we've got the point 4, 6, which means f of 4 is equal to 6. I can say that 6 is equal to 4 times 4 squared over 2 minus 3 times 4 plus c. So we should get 6 is equal to 4 squared, 16. 16 times 2 is 32 minus 12 plus c. 6 equals 20 plus c. And so we can say that c equals negative 14. But the equation of the function, that's what the question is asking. So we need to say f of x equals 2x squared minus 3x minus 14 for your achieved grade. Okay, next question. We got a function is given by g of x, which is that. Find the equation of the tangent at the point on the graph of g where the gradient is 0. Okay, so what we're looking for is, first off, we need to find out when g dash of x equals to 0, and then we need to actually work out the equation. So I'm going to work out g dash of x first. So g dash of x is differentiation of x squared is 2x, differentiation of negative 3x is minus 3, 18 is just 0. So if I put 0 equals to 2x minus 3, then I get 2x is equal to 3 and x is equal to 1.5. So what I know is that when x equals to 1.5, that's when the gradient is equal to 0. I need the y value as well. So to get the y value, I'm going to put it back in g of x. So g of 1.5 equals 1.5 squared minus 3 times 1.5 plus 18. Because when I put this x value 1.5 back into this equation, it's going to give me the y value. So g of 1.5 is then equal to, comes down to 15.75. So that's what the y value is. So right now I've got an x value which is 1.5. I have a y value which is 15.75. And I have a gradient which equals to 0. So to write the equation of the tangent, I've got y minus y1 equals m times x minus x1. So I got y minus 15.75 equals 0 times x minus 1.5. Now because 0 is getting multiplied on that right hand side, that entire side is going to become 0, and what I'm going to get is y minus 15.75 equals 0 and y is equal to 15.75 as the equation of my tangent. So this is what gets you a merit, this is what gets you an achieved. Okay, let's go to the next part of this question. So it says, in relation to the graph, fully describe the point where this tangent meets the function. So what we do know is that the point that we're working with is actually 1.5 and 15.75. So let's think about it. I mean, the graph that we were looking at was actually, an x squared graph. If it's an x squared graph, it's a parabola, and that's what it looks like. What we do know about a parabola is that at one point, the gradient is going to equal to 0. Now that point is usually the vertex. It's known as the vertex, it's also a turning point, and in this particular case it will also be a minimum point. So right now, that's basically what you can do to describe this point. You basically say this point is a vertex, it's a turning point, and it's a minimum point. And that's basically it for this question, guys, to get an achieved. All right, let's go to the next question. Okay, so next question we've got is a skateboard park, blah, blah, blah. The model can be, mount can be modeled at this particular model, okay. It says, what is the maximum height of the mount? Okay, to find the maximum height of the mount, first we need to figure out where this gradient is going to equal to 0. So if h is equal to this particular equation here, the first step I need to do is I need to differentiate it. So h dash is equal to negative 1 times negative 1, so it's going to be negative x plus 3. Put h dash equals to 0, so 0 equals negative x plus 3. Rearranging it, I get x is equal to 3. So all I know is that when x equals to 3, that's when the maximum happens. So I go back to my original function of h, and I'm going to put h of 3, which means I've got negative 0.5 multiplied by 3 squared plus 3 times 3 minus 1.5. Which should give me an answer of 3 meters. So grades wise, merit achieved. And now we go to part 2 of this question. So part 2 says a ramp up the side of the mound is a tangent to the mound. Ramp can be modeled by the function 0.5x minus c. Okay. Use calculus to find the vertical distance below the top of the mound where the ramp will meet the mound. Okay, to kind of like try and figure out what they're asking in this question, I'm just going to show you guys where the top of the mound is. Okay, that's where the top of the mound is. And they're saying find the vertical distance below the top of the mound where the ramp will meet the mound. So what we're looking for is this purple line here. Okay, I'm going to put a blue line here, which is going to be, so this, I hope you guys can see that. Well, maybe I'll put a different color. Hold on. I'm going to put like something like a bright color so you can see a bit better. So that orange line there is from the top of the mound to where the ramp actually meets the mound. The blue line is from the ground level of the mound to the height of the mound itself. Okay, so what we do know is we've got the gradient function for h, because we did that previously. H dash is equal to negative x plus 3. At this point where the ramp meets the mound, the gradient is equal to 0.5, because that's what that equation is. Okay, I guess it's one of these really weird questions. They shouldn't really have used h here. They could have used any other letter, but they used h. But anyway, we're going to have to work with that. So we want to know at what point is the gradient equal to 0.5. So if I put 0.5 negative x plus 3, then I'm going to get x is equal to 3 minus 0.5. X is equal to 2.5 meters. So what this 2.5 actually tells me is that distance there. Okay, so if I go back to my original equation, which was the original h equation, which was 0.5 x squared plus 3x minus 1.5. So this was my original h equation for the parabola curve. So if I put in 2.5 in here, I'm going to get negative 0.5 multiplied by 2.5 squared plus 3 times 2.5 minus 1.5. And when I do this, I actually end up with 2.875 meters. Now this is the blue part. Okay, if I want to figure out what the orange part is, remember that in the previous question that we did, we actually figured out the, I'm going to put a different color here, I'm going to put a red one. That distance there, the maximum height was 3 meters. So if I go 3 meters minus 2.875 meters, I actually end up with 0.125 meters, and that is the orange part, which is distance. So we can just put a little note here: distance below height of mound. And that's basically it for this question, guys. Excellence to get all the way up to here. Find height of where tangent meets the curve. So possibly here you're looking at a merit value of x, looking at achieved. Okay, let's have a look at the next part of this question. Alright guys, so for this question, the first thing you need to notice is that what you have here is a cubic, a positive cubic. A positive cubic looks like this. We know that there's the gradient at this point and this point is going to equal to 0, where this will become the maximum point, this will become the minimum point. And if you look at the slopes itself, the slope is increasing here, decreasing between maximum and minimum, and after minimum the slope is increasing. So what we're going to do is we're going to figure out where these turning points are. So for the first thing we're going to do is we're going to write down our equation, work out what h dash is. So h dash is going to equal 3r squared over 3 minus 4r plus 3. Simplifying this, we have r squared minus 4r plus 3. We want to know when the gradient is equal to 0, so we're going to have to solve the two equations. Chuck this in your calculator, guys, and you should get r is equal to 1 and 3. So the next thing is I need to figure out what the height is when r is 1 and when r is 3. So I'm going to figure out what h of 1 is. So that's going to be 1 cubed over 3 minus 2 times 1 squared plus 3 times 1. Simplifying this, I'm going to get 4 over 3. Then I've got h of 3, which is 3 cubed over 3 minus 2 times 3 squared plus 3 times 3. And when I do this, I actually get a value of 0. So using this right here, I could actually say that, well, just looking at the comparing the h values, I can see that h of 1 has to be the maximum value, h of 3 has to be the minimum value. And what I can also say is that for starters, the curves are within the height restrictions, because if you think about it, the question actually asks that it cannot be more than 3 meters above the ground. So I can basically say height, one of the comments is height is within restrictions. And then comes the next part. So because, and I guess this is where this information comes extremely useful for you guys, because we know that when it's maximum, that's going to be positive 1. When it's minimum, it's positive 3. So what I can say is that when x is less than 1, function is increasing. Okay. When x equals to 1, it's a maximum point. And between 1 and 3, it's decreasing. And then greater than 3 for x, it's once again before I forget, when x equals to 3, it's minimum. When x greater than 3, it's increasing. And I think that's what you guys need to do for this particular question, guys. This is an excellence question, and you need to get all of those categories right at the end. Coordinates of both turning points find, and with justification of each graph. Okay, now you could do it this way, or you could do with second derivative as well. Either way, it's fine. In terms of merit, just finding your two coordinate points of turning points found. So turning points found. So you're probably looking at these two things. The R values of turning points found is achieved. So this would become achieved. Okay. Let's go to the next question. All right, so question 3a, we've got velocity of a function. Find the acceleration of this object. So that's nice and simple to go with. Just differentiation of velocity. So 4t cubed differentiates to 12t squared. T squared differentiates to negative 2t, and 2t differentiates to 2. That's your achieved right there, folks. Next question. So find the equation of the tangent to the curve. This is the equation at 2, 2 on the curve. So what we're looking for is equation of the tangent. We need f dash of x. So if f of x equals to this, then f dash of x is 3x squared minus 4x plus 1. So the next step is we want to figure out what the gradient is when x equals to 2. So then we have 3 times 2 squared minus 4 times 2 plus 1. And when we do this, we figure out the gradient is actually equal to 5. Is it? Let's see. We've got 12 minus 8 plus 1. Yes, the gradient is equal to 5. So the next step is then to try and find the equation of the tangent. So we've got the gradient. So gradient is equal to 5. X is equal to 2. Y is equal to 2. So our equation of tangent is y minus y1 equals m times x minus x1. So we got y minus 2 equals 5 times x minus 2. And expanding it out, we get 5x minus 10, and y is equal to 5x minus 10 plus 2. So tangent's equation is 5x minus 8. So grades wise, merit for this, derivative and grade found gets you an achieved. Okay, let's go to the next question. So for the next question, it says in an area surrounding a farming strip there's a height restriction. Okay, 50 meters. Fireworks after it's fired. Okay, so basically what we have is we've got a parabola that we're working with, and we're trying to figure out, will the firework break the 50-meter limit? So what we can do is differentiate the function equal to 0, find out that, because when we put it equal to 0, it'll give us what t is. Sorry, let me just do that again. It will give us what t is, and then we can go back and put in the equation to figure out what the height is. So we've got height is equal to 20t minus 5t squared. So h dash is equal to 20 minus 10t. So we want to know at what point is the gradient 0. So we put h dash equals to 0, 20 minus 10t. So 10t equals 20, t is equal to 2. So at 2 seconds, it's going to be reaching its maximum height. So if we go and find h of 2, we got 20 times 2 minus 5 times 2 squared. So we've got 40 minus 5 times 4. So that's equal to 20 meters. So as you can see, firework will not break restriction. And that's basically it for this question, guys. Merit for this point, maximum height found, and you got to state a conclusion, all right? If you don't state a conclusion, it looks like you might not get that full grade. And for achieved, you're looking at this part here. Okay, let's go to the next question. All right, so what we have is, I know the spacing, I've done it slightly different, and there's a reason for it, but anyway, look, I'll just show you guys how it works out, okay? So we got a function y equals negative ax squared plus bx plus c. A, b, and c are positive numbers, and b equals 2a. That's all we know. On the grid below, sketch the gradient function. Show the values of all intercepts. The y dash intercept should be given in terms of b. Okay. What we know is, we know that y is negative ax squared plus bx plus c. What we also know is b equals to 2a, but I'm going to actually differentiate this first. If I differentiate y dash, I'm going to get negative 2ax plus b. Okay, that's what I know. The next thing is I know that b is equal to 2a, so I can replace this with y dash equals negative 2ax plus 2a. But the problem is the y-intercept should be given in terms of b. So obviously I do not want to have any a's in of my equations. So what I really should have done is I should have written this as y dash is equal to negative bx plus b. Because if you think about it, in this equation, my y-intercept came out as 2a, right? But in this equation, my y-intercept comes out as b. So I've got y dash equals negative bx plus b. So which means I've got my y-intercept, which is, I don't know, let's just put that as b. That's my y-intercept. Now I need to figure out another point. And I know that I can actually figure out what the x-intercept is, because if I put y dash equals to 0, it'll give me what the x-intercept is. So I'm going to put 0 equals negative bx plus b. And if I rearrange it, I get bx is equal to b, x is equal to b divided by b, x is equal to 1. So the x-intercept happens to be at 1. And now I have my 2 points for this equation, which is going to be a straight line. So I can sketch a straight line. Now guys, I'm sorry about this, but this is the best straight line I can do. Okay. Obviously you guys, when you do it, just do it with a ruler and you should be good to go. All right, so that's what you need to do for an excellence in this particular question. There's a few other things for you to get merit and achieved. For achieved, if you find the equation of gradient function found, it's an achieved, so you can possibly get an achieved here. Either using 2a or b, so you could actually use this, or that. Graph sketched with one intercept correctly identified. So you still have to identify one intercept to get a merit. So either that or that. So yeah, it's just a few little things that you can do. But anyway, that's it for this question, guys. Let's go to the last question. So with this question, guys, the first thing it says is that y is the value of x after 3 has been subtracted and then the answer doubled. So then what we'd have is y is equal to x minus 3 multiplied by 2. So we can rewrite this as y is equal to 2 times x minus 3. Now it says x is between negative 0.5 and 3. And then it says find the maximum and minimum values of the product of x squared y. So product of x squared y can be written as p is equal to x squared y. We know that y is equal to x minus, well, 2 times x minus 3. So expanding this out, we're going to get 2x cubed minus 6x squared. So we want to figure out what the maximum and minimum values of p is. So we got to differentiate it. So when we differentiate it, we get 6x squared minus 12x. And then for maximum and minimum values to happen, we know that p dash has to equal to 0. So we got 0 equals 6x squared minus 12x. So 0 equals 6x multiplied by x minus 2. And therefore I can say x is equal to 0 or positive 2. So those are my two values for p when the gradient is equal to 0. But I need to figure out what the y values are. So what I'm going to do is I'm going to work out what p of 0 is. So p of 0 is, I've got 2x squared times x minus 3. I've just simplified it, guys, just basically from here to here. Okay, I've just moved the 2 in front, that's all I've done. So if I do p of 0 is equal to 0 times 0 minus. So when I do this, what I get is p of 0 is equal to 0. Okay, but what about the y value? The y value is going to be 2 times x minus 3 which is 2 times 0 minus 3, and that gives me a value of negative 6. So I want you guys to think about it like this. When x is equal to 0, y equals negative 6, and p is equal to 0. So that's the first thing. Second thing is p of 2. P of 2 is 2 times 2 squared multiplied by 2 minus 3. So p of 2 is equal to 2 times 2 squared is 8. 8 times negative 1. So p of 2 equals negative 8. As for y value, you've got 2 times x minus 3. 2 times 2 minus 3. And you're going to get negative 2 as the y value. So when x equals to 2, y equals negative 2, and p is equal to negative 8. So what I've done is I've actually figured out what the maximum and minimum values for p is. And straight away you can see just by the values with 0 and negative 8 that relatively that's the highest. But what you can do though is you can actually do double differentiation, and because I haven't actually done it at all in this particular video, I'm going to show you guys how to actually do it. So with p dash, I have p dash already as 6x squared minus 12x. P double dash would then equal 12x minus 12. What I need to do is I need to put p double dash of 0. When I do that, I get negative 12. And because p double dash is less than 0, this is considered a maximum point. When I do p double dash of 2, I get 12 times 2 minus 12, which equals to positive 12. And because p double dash of 2 is greater than 0, the point has to be minimum. So in here, I've just justified why this is a maximum and why this is a minimum. And that is what is going to get you your excellence grade. Value of the product found of both values of y found, so it's merit. Merit could be like a combination of either getting y values or getting p values. Achieved is somewhere along here, and correctly differentiated as well. Cool, that's it for this question, guys. Alright, that's basically it for this session, guys. As usual, thank you for watching. Don't forget to like, subscribe, and share. And good luck for your exams. If you have any questions or comments, just leave it in the comment section and I will try and get back to you. Once again, thank you for watching.